goal of this video is to help you understand the weird ones and zeros in computers, which are called binary numbers. Everyone now is almost dependent on computers in some shape or form. Understanding binary numbers will help you get a better idea of how computing works on a low level and appreciate it more. Before we try to understand the binary system, let's try to understand the decimal system, which all of us know and use in our daily lives. The decimal system is the oldest and most widely used numbering system, which is also known as base 10. Numbers based on 10 were commonly used in ancient cultures too. This system was derived because we could use our fingers to count. The decimal number system uses 10 different digits, from 0 to 9. Notice how this is from 0 to 9 and not 1 to 10, because 10 is a combination of 1 and 0. The best way to understand this is with an example. Let's take the number 43. Now I want you to think of the two parts of this number, the 4 and the 3. We can easily see that 43 is 40 plus 3. But do we really understand what this means? We can say the rightmost digit represents the least significant decimal, which is 3, which can also be written as 3 into 10 to the power of 0, because it is base 10. And 10 to the power of 0 is 1, therefore it is 3 multiplied by 1. And the digit 4, which is the most significant digit, is written as 4 into 10 to the power of 1. Overall, we can write this as 4 multiplied by 10 to the power of 1 plus 3 multiplied by 10 to the power of 0, which is 4 into 10 plus 3 into 1, which is 40 plus 3, which is 43. To drive this point home, let's do another example. Take the number 2058 and try to represent this in base 10 in the same way as before. Go ahead and pause the video and try it out. I hope you managed to get it. The least significant digit is the rightmost one, which is 8. Therefore, it is 8 into 10 to the power of 0, which is 8 into 1, which is 8. Also, notice how we are reading it from the right to left and how I've listed the powers of base 10 above the numbers, which is a good habit to have. So the next number from the right is 5, and the second digit from the right, therefore, is 5 into 10 to the power of 1, which is 5 into 10, which is 50. The next digit is 0, and it is the third digit from the right, and therefore is 0 into 10 to the power of 2, which is 0 into 100, which is just 0. The fourth and last digit from the right is 2. Therefore, it is 2 into 10 to the power of 3, which is 2 into 1,000, which is 2,000. The addition of these would be 8 plus 50 plus 0 plus 2,000 gives you 2,058. Now, you must be wondering why we did this exercise, but as you'll see, the process is very similar for binary numbers. Now that we understand how decimal numbers work, which are of base 10, let's look at binary numbers, which, as you can tell from the name binary, are base 2. We saw base 10 single digits can go from 0 to 9. So following the same logic for binary, it is from 0 to 1, as there are only two possible digits. A bit is a single binary digit. Let's take the example of a binary number 101. Make sure you don't confuse this for the decimal number 101, as this is binary. So it's 101. The least significant bit is on the right, so it's easier to start from that side as we did before. Notice the base 2 powers above the digits, which were similar to the base 10 powers. Since the first digit from the right is 1, it is 1 multiplied by 2 to the power of 0. And as 2 to the power of 0 is 1, this is 1 multiplied by 1. The second digit from the right is 0, and it is multiplied by 2 to the power of 1, which is 2. Therefore, it is 0 multiplied by 2, which is 0. The last digit is 1, and it is multiplied by 2 to the power of 2, which is 4. So it is 1 multiplied by 4, which is 4. Overall, the addition would be 1 multiplied by 2 to the power of 0 plus 0 multiplied by 2 to the power of 1 plus 1 multiplied by 2 to the power of 2, which is 1 multiplied by 1 plus 0 multiplied by 2 plus 1 multiplied by 4, which gives us 1 plus 0 plus 4, which is 5. So the binary number 101 is the representation of the number 5. Let's do another example to solidify things. Take the binary number 10101. Pause the video and try to convert the decimal for yourself. Let's see if you got it right. Starting from the rightmost bit, 1. It is 1 multiplied by 2 to the power of 0, which is 1 multiplied by 1, which is 1. The next, to the left of it, is 0 multiplied by 2 to the power of 1, which is 0 multiplied by 2, which is 0. The third bit from the right is 1, and is 1 multiplied by 2 to the power of 2, which is 1 multiplied by 4, which is 4. The next bit is 0 multiplied by 2 to the power of 3, which is 0 multiplied by 8, which is 0. The last bit, which is the leftmost bit, is 1 multiplied by 2 to the power of 4, which is 1 multiplied by 16, which is 16. The overall calculation would be 1 plus 0 plus 4 plus 16, which is equal to 21. Hopefully now you understand how simple binary numbers are. I would suggest practicing converting binary numbers to decimals, and vice versa. Here's a few problems you can try out. Post your solutions in the comments below. Thank you for watching, and I'll see you in the next one.